Alright, today's the third and final day of fundamental theorem of calculus. So I'll be starting out today with a problem where you guys are going to be using your graphing calculator. The parts that you need to be able to do are parts A and C. And what I'm going to do is you guys can go ahead and use whatever calculator it is that you're using and see if you can come up with the correct velocity equation. So you're supposed to do this in for a cubic regression. So what you're going to do is you're going to plot each of those into your stats. And if you can't remember how to do that, that's something you're going to bring up during class, and we can have that discussion again about how we go about finding the cubic regression model. This is the answer. I'm going to go ahead and just write down the answer that you will get once you run that cubic regression model onto your calculator. So if you get this answer, you have done the regression models correctly and you don't have a question about it. However, if you can't come up with this answer, make sure that you ask this question during class. The next thing on this was part C, and in part C, there is a way to enter these integrals into the calculator. So if you know how to enter them into the calculator, you'll be good to go. If not, you will also need to ask this in class. I'm not spending time going over this thing right now in this video because it takes too long to try to explain to you when it would be easier just to explain in class depending upon which calculator you have. There's many different calculators out there. So what you would be doing on this part is you would be integrating the cubic regression model that you have gotten, and you can actually enter this straight into the calculator, so you're not doing this by hand, and I will be happy to also go over that in class as well. Getting on to some of the other problems here, what we're going to do is we're going to talk about finding big F, which would be the antiderivative of the function, and we're going to evaluate it when x is 2, x is 5, and when x is 8. So what we're going to do is we're going to go ahead and say, well, big F of x, which would be the antiderivative of this, would be negative cosine of theta. And we're going to evaluate that from 0 to x. Well, for each one of these, we're going to plug in 2 and then 5 and then 8. Well, I'm going to go ahead and just create it as a function of x first. So we would have negative cosine of x minus, I'd have negative cosine of 0. Well, we're going to go ahead and simplify this. When we simplify this, we get negative cosine of x plus cosine of 0. Well, the cosine of 0 is 1, so I could simply write this as 1 minus cosine of x. Now I'll be able to evaluate each of the antiderivatives at 2, 5, and 8 just by plugging those in. So f of 2 would be 1 minus cosine of 2. F of 5 would be 1 minus cosine of 5. And f of 8 would be 1 minus cosine of 8. Now you can go ahead and put each of those into the calculator, or we can just go ahead and leave those in that form.